So if you have bell-shaped data, and that's a huge if you have bell-shaped data, big if, this is only going to work when you do have bell-shaped data, if you have bell-shaped data. And the good news is you often do. I just recently ran an experiment in 244 trying to identify touch therapy, the human energy field, to see if touch therapy's main premise holds. The data I got back from them, which had no reason to be bell-shaped, was bell-shaped. I was like, well, hot damn, look at that. Now we can utilize these percentages. So when you have bell-shaped data, which does happen quite a bit in the world, we'll study that more and more as we go through this class, you get, the reason you do the happy dance statistically is you get some stuff for free. Okay? So roughly 68% of your data is within one standard deviation, x bar plus or minus s. That's called one standard deviation. One standard deviation. Roughly 68% of your data is within one standard. This was not a happenstance that we got the 69%. That's almost 68%. It's damn close. It's also probably due to rounding error, isn't it? I mean, I rounded those s values, those x bar values off. So there's some precision loss there as well. But it's not coincidental. Roughly, I often call this 2/3. Roughly 2/3. So roughly 2 out of every 3 data points lie within one standard deviation. Which I love, because it goes back to the idea that that's where the big chunk of your normal data lives. I love that, thinking about it that way. But statisticians don't like using those cutoffs as unusual for data. They say, you know what, that's throwing away or flagging too many things as unusual. So they tend to use 2. And this is cool because you get about 95% of your data is within 2 standard deviations. 2 standard deviations. That one is the one that's very, very commonly used. Those of you guys that have taken psych and social classes, you ever heard about a p-value less than 5%? Who's heard of that in their psych and social classes? P-values less than 5%. P-values less than 5%, that means your results landed in the tails, outside of the 95% in the middle, which means something interesting happened. You found outlier results, which means you scratch your head and you go, why did I get outlier results? You're either in the left tail or the right tail of that curve. This is what 244 is all about, FYI. 244 is all about flagging those outliers and then asking why. Why is it an outlier? Is it an outlier because we sneezed while taking a measurement and therefore should throw the data away? Or is it an outlier because ibuprofen seems to lower inflammation in shoulder injuries? Boom, it does. But is that why it's an outlier? So that raises more questions. But that's why those p-values less than 5% are talking about that 95% right there. And there are other ones too. If my memory serves me correctly, you get almost 100% of your data within 3. Almost 100%. It's like, I think it's like 99.7% is within 3. I'm going to go by memory on this one too. You get about half of your data. You get about half of your data within 2/3. I discovered this one a few years ago. Nobody ever talks about this one. About half of your data is within 2/3 of a standard deviation. I think we should check that on our data and see if it holds. I think we should check that. Let's check that one ourselves. What would 2/3 of a standard deviation be for our data? Actually, x bar is not x, by the way, guys. Sorry about that. What would 2/3 of a standard deviation be for us? 10.9. Thank you, guys. Thank you. 10.9. So if S is 16.4, 2/3 of S is 10.9. Let's check our data. Let's see how much falls within 2/3 of a standard deviation, shall we? So you'd have to add and subtract 10.9 from negative 14.7 and then see how many data points fall in there. Let's turn the camera off and figure that out.